Great, thank you. Hello, everyone. My name is Frederic Louis, and I'm officially working actually for RENATER, which is, you have guessed it, the French Education and Research Network. And today I'm with my GEANT hat as a RAR technical leader, and I will talk about a very exciting project that we have started 2 years ago, 2.5 years actually, which is called Router for Academia, Research and Education. So let's move further. So RAR is an EC-funded project that is occurring under the GEANT program umbrella. GEANT, as you might already know, is the association that is managing the pan-European network, and it's an ambitious project that that has a specific goal. The goal is to create one familiar platform that provide multiple solutions, and each solution will be able to address specific research and education use case. It's a very important mission statement for the project, because all the result that you will see will be the consequence of this mission statement. So why are we trying to? Why are we thinking that it's the right moment to do that now? Well, 2 years ago. It's simply because we are seeing more and more technology that begin to be accessible and get more maturity, like DPDK and NP4. Historically, we also see a lot of control plane software like Bird, ExaBGP, VYOS, Quagga that were developed and got improved every single day. In our case, we choose to use FreeRouter control plane, and there is 3 obvious reasons for that. The first reason is that we have the lead developer inside our team, which is a very great asset when you have a 24-month project that needs to provide some interesting result. The second thing is that if you look at the mission statement, we are more focused on providing a router for academia research and research and education organization. So we are not trying to create the best of breed router for the cloud or a CPE. We are really trying to stick with this mission statement. So this is the second reason why FreeRouter is used. It's simply because it boasts a lot of features that is more toward the one aspect. So the service provider space. And the third reason is that I can say it now is that for having been used FreeRouter since 6 years ago, it's one of the rock solid and stable control plane we can have in the open source world. And you will see that there are a lot of features that are really interesting and that you can find only on very well-known commercial control plane. So this slide is simply here to describe you something you already know, the free tier model, where you have on the right the core, on the the aggregation and the access. This is actually the same in the service provider, in the internet service provider landscape. However, in this situation, you can imagine that all the pipes that are linking, all the green boxes are highways. When I mean highways, is that this box can be connected at 100 gig. On the left hand side, you have the access layer. Usually we are calling it CPE or small office, home office, but sometimes in the RNA, this means that the access layer can host a computing center that is connected with multi-100 gig port. So this is quite specific to the RNA use landscape. On the right hand side, on the core, you have basic function that you already know. You have the LER use case, the LSR use case, and all of our pure core backbone elements that you will find in your environment. In the aggregation layer, you have the everything related to data center, use case, internet exchange point, and this is where you will have you will have some equipment that can bridge the gap between 100 gig and 1000 gig connection. One assumption we decided to take here is that we would be, of course, IPv6 compliant. So basically, just to sum up, we are aiming for an open programmable platform for emerging NREN, but keep in mind that even if you have in your organization this mindset to host your own routing platform, this is not only if you have the possibility to do that. I invite you to consider looking at data plane programmability, because it will help you to create more and more new services. What is really important in our case is that we are aiming to provide internal global research project some new services based on connectivity. You have new you have a new project like LHC or LSST who are requiring a tremendous amount of traffic, and in a sense they really need this type of connectivity. So I won't go into the detail, but these are the research and education use case. And in that case, what we started, as we started from a blank page, we decided to study, to do our homework with P4, with various P4 target. I'm not sure if you are familiar with what is a P4 target, but a target is simply a hardware or the target emulated hardware. So in this case, we have done our homework and learned the P4 language using BMV2, which is a behavioral model. It's a virtual switch able to ingest P4 program so that you can switch packet virtually on your laptop and do a lot of tests. So this was very great to start with. And then we decided to along the progress, we decided to test our program with real hardware, like the Wedge 100 BF32X. This hardware has a specific Ethernet programmable ASIC, which is called TOFINO, that is able to, based on a P4 program, is able to switch your packet at 6.4 terabits per second, which is gigantic. It's enormous. In our case, we can't imagine to write a program that able to switch at this speed. Just to let you know that recently we are talking about TOFINO 2. TOFINO 2 is the new Ethernet programmable ASIC, but now they are double the bandwidth. So instead of being able to switch to handle 6.4, we are able to handle 12.8 terabits per second. So each port having 400 gig bandwidth capacity. We have also started to study FPGA, but for some reason we could not get a hand on the hardware and move forward with that, but we will see that in the future. If you remember the mission statement, we are trying to match every use case, and in some RNA use cases, we have lower capacity organization that have lower capacity. Some emerging NREN who don't have dark fiber, and the idea here is to have a platform that is able to switch at 100 gig, multiple 10 gig, and maybe a couple of 100. And in this case, we started to our study by studying a specific target called ELTE, which is a BMB2 with GPDK. We have done a lot of tests, and this was not concluding. We could not compile our code against it. And then we decided to write our own GPDK data plane code. The idea of this is that it is mimicking the P4 program, but using DPDK. That's simple. It is as simple as that. One thing that we are studying now, but we are blocked for legal reason, is that we are studying how to move forward with NPL in order to port our code to Broadcom switches that have Trident for example, network processor. As a glance, this is the P4 testbed. No, not testbed, but P4 lab we have deployed. In the center, you have the European part: Amsterdam, Frankfurt, Budapest, Poznan in Poland. And here on the left, we have this core lab is connecting some countries here. So we have a lot of various connection in Europe, but what you can see here, we have one leg in Latin America and here in the US. From there, we will be able to reach all the P4 equipment that will be provided by US research and education like ESNet, Caltech, and Internet too. If you look at on the right, we have a Spirent here, and the Spirent here is a tester that helps us to do a RFC compliance test. So I will detail this further in the next slide. But as you know, we have spent a lot of time in developing the platform, but we had to find a way to provide also visibility to this platform. And what we decided is to reuse a service that we are also developing in the GEANT project, which is called NMAS. Sorry, there is a typo. It's NMAS, not NMS, RAS, NMAS. And the idea of this is that on the right, you have a Kubernetes cluster that have microservices that is able to reach the out-of-band management by specific VPN tunnel. And this is how the P4 switch are managed. From there, we are able to access a store, like an Android store or something you are very familiar with, or an Apple store if you like Apple. And you have this very shiny icon. You click on an icon and deploy, and then in few minutes you have the possibility to use directly your microservice on the fly, assuming you have this connectivity before with the network element and the microservices, which is ensured by a pfSense VPN. pfSense VPN is not something that is enforced. You can have, for example, MPLS VPN or another type of VPN, GRE. The only idea is to have connectivity on top of that. Here, the first use case for NMAS was to target small institutions. So the VPN flavor was the best to do that. For very big backbone, I don't recommend to use such type of management over the internet, but it's another discussion. So here you will see there is a Prometheus database that is interrogating the P4 switch. You have and we have deployed Graphana on top of it using this paradigm, and it's working well because we have the actually in the RAR platform there is a Prometheus agent. This Prometheus agent can be programmed or configured to provide some type of information. And it's quite great to use Graphana on top of that. If you're interested, these Graphana dashboard are publicly available. You just go to graphana.com or .org, I don't remember exactly, and then search FreeRouter on the dashboard, and you will see all the dashboard that are publicly available that you can use it just if you are using the RAR platform. So what is important to know now is that we are ready to roll into production. When I mean that we are ready to roll into production, it means that all the code we are producing is after each commit we have automated testing. We have 2,300 tests that are triggered automatically every time the code is modified. So this helps us to verify non-regression code into the control plane, but also in the data plane. The parent here was used also to do this test. And as you know, when you are piloting a Formula One, you can't take all the luggage you want. So when you are working with a hardware like TOFINO switch, which is able to switch packet at 6.4 terabits per second, you have to have compromise. You need to have you need to find a good compromise regarding the function you want to achieve in the end and the platform. And this is why I'm talking about. I'm mentioning P4 profile calibration. Simply, it means that the box can behave differently depending on the resource allocation you dedicate to your profile. If you have a long time ago played with 7600, or you have this SDM profile in Cisco that you can tweak, so your box can behave more as MPLS router, multicast router, IPv4 and IPv6, and so on. DPDK, our DPDK flavor is already running in, it's already in operation. And we are running it in University of Murcia and in Kifu, which is the Hungarian Education and Research Network. And we have work in progress to put a specific box that I will show you later in production. So it's interesting to talk about research and education use case, but what can interest you? What is your use case? I would say, what are the commercial use case? And here you can have an example of a CPE for service provider. Here, if you see it, this is actually my home router using DPDK, RAR DPDK. I'm using it since 2 years. And we are having this conference via this. All the packets are going through this router now. So you are seeing that you can see that we have a 6 chipset. It's a Intel i211 chipset, and they are handling 1 gig each. And I have a J19 Celeron CPU. That's as soon as I have activated DPDK on top of that, the CPU load dropped to 20%, which is great. So this is running 24 hours by 7, and this is one of the example of a use case, of a SOA use case with DPDK. This one is quite interesting also, especially after the first session I saw. This can be a BRAS, a router where you have a flexible amount of type of interface, like 100 gig port and 32 1025 gig and one 1025 gig. Sorry. This is quite interesting because this one with our code can behave as a BRAS router. We have a profile that will convert this box to an aggregation router able to handle L2 specific BRAS function like L2TP, PPPoE function, and of course all is running on MPLS, EVPN or VPLS, depending on the current existing layer 2 flavor you have in your backbone. This is a pure LSR router, label switch router. So I have seen only this scenario in a big telco like Orange France Telecom, for example, where you have a P core distinguished that is distinct from the provider edge. And this one can give you a 4-direction P router at 100 gig. This is extremely tremendous. It's great to have this type of, because what does this mean? It means that you can have 800 packet core that is able to handle 800 gig, that can switch packet at 800 gig, which is great. And this is the smallest one. With TOFINO 2, you can now reach twice the bandwidth, which is 1.6 terabits. So you can have 4 direction with 5.6 terabits with the new TOFINO 2. With the sandbox, we can transform it and make it as a provider edge, having a nest west direction, and with that in mind, you have also the possibility to aggregate 1,600 gig connection for your user, which is gigantic. So,
Frederick, this is Leo. Just letting you know you have 5 minutes before the Q&A starts.
Sure, I will finish soon. So, so here in this case, this is a server that can have, for example, 64 gig of RAM, and so as you know, you can handle the full routing table with 4 gig. So so I will let you do the math, but it's a unparalleled route reflector. In this case, you are reusing the same server, but now instead of having a route reflector, you can have a very interesting provider edge router able to switch packet with DPDK. And the idea here is to have 100 gig connection connected to a switch, aggregating the router, and then being able to switch the packet towards your core using the wedge you have seen before as LSR. This is only the tip of the iceberg. The sky is the limit with this open programmable model. And actually, we just really need your creativity on that. I will give you an very brief example. We have a colleague at home. He's running FreeRouter, and when he's leaving his home, actually the MAC address is disappearing, and then he's lowering the temperature of the thermostat, and then he's shutting down the head. It's not that much, but if you think at the scale of a campus, of a high campus, a university of big companies in the US, for example, you can see the money you can save just by this type of programmable behavior. If you want to improve the situation, and assume that you have some windows that can be shut down via software, if the MAC address is disappearing, you can shut down automatically the windows. Same story. In France, you have the new concept where you have a radiator, but each radiator is composed by a series of blades from ARM server. And actually, it's a mini cloud in the radiator. You can put it, and if you need to adjust it with your routing, you need more compute power and more head. You just add you just advertise a new prefix in your backbone, and then you are able to route to provide a new compute resources. This is just as simple as that. Nothing is perfect. As I said, we have spent a lot of time managing the platform, creating a feature for the platform. We think that we have a lot of things to do in the network management side, because this platform is able to do streaming telemetry, INT, and then when we are talking about that, it's a tremendous amount of data to analyze. And I'm not sure if the network management platform we usually know as it is now are able to analyze such type of traffic. We are also this is also a possibility. There is also the possibility with this project to close the dot with project related to automation, network automation. Final takeaway. We are able now to provide instantaneous and flexible network service for the user. 20 years ago, I had a discussion with my director, and he said to me that for a telco, it's around 6 months or 8 months to have a new service land on the consumer market. With this type of new programmable paradigm, it's possible to reduce this time. Last use case that I'm preparing for RENATER, it's that you are creating a private peering node aggregation. Essentially, it's a simple node that is connected to a 400 gig bundle, and then that is able to have 1,600 gig private peer. I will let you do the math when you will have all the figure in mind, but the price is different. I mean, in terms of TCO or ROI, you will see the difference. Some useful links, you can go to FreeRouter.net where you will get the control plane. rar.freerouter.net is the rar project. Blog is the blog where you will find all the examples related to private peering box and the root reflector and small office, home office. docs.freerouter.net, and then you will have the mailing list if you want to reach us, rar user, rar dev, and our Twitter if you want to subscribe and be aware of what we are doing instantly. This is the source code. So everything is open source. So you can create your own backbone now. Feel free to test it, give us feedback. We would like to thank all this project because these are really backbone projects that help us to achieve what we could show you today. Thank you.
Thank you, Frederick. Just to remind all the attendees and participants that we will now be having a poll. A poll will show up on a screen for us to please rate to give feedback for Frederic's presentation. During this time, we can have an opportunity to go through the questions that have been posed. We have a question from Blake Willis. It says, which smart NICs are you supporting with your DPDK build? Any plans for the new DPUs in the future?
A very great question. For now, we are supporting all the smart NICs that are mentioned in DPDK website. So mainly Intel and Broadcom and Mellanox. And I am in touch with NVIDIA. And as soon as we have access to a DPU card, we can think about trying to see how we can compile our code against the P4 stack from NVIDIA. Oh, sorry, I forgot to say that, but just in case, we have recently started a hardware compatibility list, and just in case you want to work with us, feel free to give us access to hardware, or better send us hardware if you are a vendor, and we will be glad to certify our code on your platform.
Awesome. The second question is from Kathal Muni, and the question is, what was the model or device you used for the Soho router use case? Looks great.
Oh yes, I don't want to. It's a very low. It's a low end hardware. It's $200. I can send you offline if you can provide emails to Portia. I can send you offline. The idea was not to do some publicity to specific website and so on. So this is a voluntary, but I can send it to you. If you want something more, which not, I won't say professional. It's not the right word, but something less exotic. What you can do is to consider to buy a VEP from Dell. You have a very good, interesting platform that, actually I have some project, I have some plans because in France, we have some schools that are unconnected via FTTH. And the idea is to create a VEP, to deploy a VEP that interconnect these schools with this type of platform. So for now, they are using free range routing. I will try to discuss with them and see how we can move forward with that. But just have a look. But if you really want to look at my platform, I can send you the direct link. It's roughly $200.
Thank you. Oh, sorry. Thank you so much, Frederick. And thank you to everyone for all the questions. Those are all the questions that we had for you. So thank you, and I'll hand over back to Merrick.